So we will discuss the product rule. Let us consider two functions f of x and g of x. Now let's suppose that the both of the two functions are differentiable, meaning we can differentiate the two functions. Then this means that if we take the product of these two functions, then this is also differentiable. And in order to differentiate the product of the two functions, we use what is called the product rule. So let's say we take the derivative with respect to x, the product of the function f of x times g of x. All we have to do is follow the method. So we take the function f of x and multiply it to the derivative of g of x. Plus, since we took the derivative of g of x, now we will leave it aside and multiply it to the derivative of f of x. So we can follow any order. It's not necessarily that this has to be the first term. We can start by differentiating f of x first and multiplying it to g of x, and then add it to the f of x and multiply it to the derivative of g of x. So in order to understand this, let's consider an example. Let's say we have a function f of x given by e raised to the power of x. So this is the exponential function. And we have another function g of x which is given by x raised to the power of 5. Then f of x times g of x, the product of the two functions, will be simply e raised to the power of x times x raised to the power of 5. So now what we have to do? We have to find the derivative of this product with respect to x. So let's apply the formula. So we have e raised to the power of x. We will multiply it to the derivative of x raised to the power of 5 and add it to x raised to the power of 5 multiplied to the derivative of the exponential function. This will give us e raised to the power of x. To differentiate x raised to the power of 5, we use the power rule. So this will be simply 5 multiplied to x raised to the power of 5 minus 1 plus x raised to the power of 5 multiplied to derivative of the exponential function, that will be the exponential function itself. So this is the final answer. So we can rewrite it as we have 5 times x raised to the power of 5 minus 1 will be 4 multiplied to e raised to the power of x plus x raised to the power of 5 times e raised to the power of x. So this is the derivative of the product of the two functions given by f and g. Let's perform another example. So here we have g of x given by x raised to the power of half multiplied to 5x minus 3. So using this, we need to obtain the derivative of g of x with respect to x. So let us begin. So we have to find out ddx of g of x. That is, we have to find out the derivative with respect to x of the product of the two functions x raised to the power of half times 5x minus 3. So this is one function, this is the other function. Let's call it function 1 and function 2. So we'll take the first function x raised to the power of half and multiply it to the derivative of the second function, which is 5x minus 3. Plus, now we take the second function 5x minus 3 and multiply it to the derivative of the first function, which is x raised to the power of half. This will be equals to x raised to the power of half times, now we have derivative of 5x minus 3, so this will be 5 times derivative with respect to x of x. 5 is a constant, so we have pulled it out of the derivative, minus derivative with respect to x of the constant 3 plus 5x minus 3 times, so derivative of x raised to the power of half. So we'll use the power rule. So that is simply half multiplied to x raised to the power of half minus 1. So this gives us x raised to the power of half times 5, the derivative of x with respect to x. So that's simply 1 minus derivative of a constant is always 0 plus 5x minus 3 multiplied to 1 over 2 times x raised to the power of half minus 1 will be negative half. So that will finally give us, so we have 5 times x raised to the power of half plus 5x minus 3 divided by 2 multiplied to x raised to the power of negative half. So this is the derivative of a given function. We can also check out if this particular answer is correct or not. What we could have done is, so we had g of x given by x raised to the power of half multiplied to 5x minus 3. So we could distribute x raised to the power of half to each of the terms within the parentheses. So that will give us 5 times x raised to the power of, so we have half multiplied to x, which is actually x raised to the power of 1. So that would be 3 over 2 minus 3 times x raised to the power of half. Now, if we apply the derivative on both sides, that will be equals to 5 times, so we take the derivative of x raised to the power of 3 over 2. So this is 3 over 2 times x raised to the power of 3 over 2 minus 1. So that's half minus 3 over 2. So that 1 over 2 comes from x raised to the power of half multiplied to x raised to the power of half minus 1. So that is negative half. So this is 15 over 2 times x raised to the power of half minus 3 over 2 times x raised to the power of negative half. So we got this particular expression. If we reduce this, I mean like if we distribute 5x minus 3 over 2 with x raised to the power of half, then we would get, so we have 5x raised to the power of half plus half multiplied to, so we have 5x minus 3 multiplied to x raised to the power of half. So that will be 5 times x. So I have x multiplied to x raised to the power of half. That will give us half minus 3 times x raised to the power of negative half. So we have 5 times x raised to the power of half plus 5 over 2 times x raised to the power of half minus 3 over 2 times x raised to the power of negative half. So if we add the first two terms, then this will give us 15 over 2 x raised to the power of half minus 3 over 2 times x raised to the power of negative half. So this is exactly what we obtain using both the two ways. Let's try out another problem. So here we have the function h of x, which is a product of two polynomials, which is x raised to the power of 6 minus 5 times x raised to the power of 4 plus 2. So we need to find out the derivative of the function h of x. So let's begin by applying the product rule. So h prime of x. So we will treat this as the first function and x raised to the power of 4 plus 2 as the second function. So we begin with the first function and multiply it to the derivative of the second function. Plus, now we consider the second function, x raised to the power of 4 plus 2, and multiply it to the derivative of our first function, which is x raised to the power of 6 minus 5. So this will give us x raised to the power of 6 minus 5 multiplied to derivative with respect to x of x raised to the power of 4 plus derivative with respect to x of the constant 2 plus x raised to the power of 4 plus 2 multiplied to derivative with respect to x of x raised to the power of 6 minus derivative with respect to x of the constant 5. So now we will apply the I will apply the power rule. So we have derivative of x raised to the power of 4. So that will be 4x 4 minus 1. So this is cubed plus 0 plus x raised to the power of 4 plus 2 multiplied to derivative of x raised to the power of 6. So this will be 6 times x raised to the power of 6 minus 1, which is 5, minus derivative of a constant is always 0. So we have 4x cubed multiplied to x raised to the power of 6 minus 5. We can leave it the way it is instead of multiplying, and this should give us 6x raised to the power of 5 multiplied to x raised to the power of 4 plus 2. Now let's distribute 4x cubed with x raised to the power of 6 minus 5. So we have 4 times x raised to the power of 3 times x raised to the power of 6. So this will be x raised to the power of 9 minus So 4 times 5 will be 20. So 20x cubed plus 6x raised to the power of 5 times x raised to the power of 4. So this will be x raised to the power of 5 plus 4 is 9 plus 6x raised to the power of 5 times 2. So this is 12 times x raised to the power of 5. And therefore we should finally get, so we will add the first term and the third term. So this is 10 times x raised to the power of 9. Then we consider the fourth term. So this is plus 12x raised to the power of 5. And the second term, negative 20x cubed. So this is the derivative of a given function. There is also another way what we can do. We can, before taking the derivative, we can distribute x raised to the power of 6 minus 5 with x raised to the power of 4 plus 2. That means we can multiply the two function, and then we can also take the derivative, which should also give us the same result. So I'll leave this as an exercise for you to try out. So let's move on to the next problem. So we need to differentiate the function f of x, which is given by the product of square root of x with 5 over x squared minus 1. So let's try this out. So f prime of x, which is the derivative of f of x with respect to x, will be equals to, so we'll take the square root of x as the first function and 5 over x squared minus 1 as the second function. So we take the first function and multiply it to the derivative of the second function, which is 5 over x squared minus 1. But 5 over x squared can be also represented as 5 times x raised to the power of negative 2 minus 1. Then we have plus 5 times x raised to the power of negative 2 minus 1 multiplied to derivative with respect to x of the first function, which is square root of x, but we can also represent it as x raised to the power of half in the form of an exponent. So this will give us square root of x times derivative with respect to x. So we'll take the derivative of 5x raised to the power of negative 2. So 5 being a constant, we have taken it outside the derivative. So this will be multiplied to x raised to the power of negative 2 minus derivative of a constant 1. So that is 0 plus 5 times x raised to the power of negative 2 minus 1 multiplied to, so we have derivative of x raised to the power of half. So let's apply the power rule. So we have half times x raised to the power of half minus 1. So that will be negative half. So this gives us square root of x times 5 times x raised to the power of negative 2. So when we apply the power rule, so this will be negative 2 times x raised to the power of negative 2 minus 1 will be negative 3 plus. So let's multiply these terms. So we have 5 over 2 times x raised to the power of, so we have negative 2 and x raised to the power of negative half. So negative 2 negative half will give us negative 5 over 2 minus, so we need to multiply 1 with half, x raised to the power of negative half. So this gives us, so we have 5 times negative 2, so this is negative 10. So we have 10 times x, so here we have x square root of x, which is actually x raised to the power of half, and this is multiplied to x raised to the power of negative 3. So this is x raised to the power of half minus 3, so which gives us negative 5 over 2. So we have x raised to the power of negative 5 over 2 plus 5 over 2 times x raised to the power of negative 5 over 2 minus half x raised to the power of negative half. So we can combine the first term and the second term, and this should give us negative 15 over 2 times x raised to the power of negative 5 over 2 minus half times x raised to the power of negative half. So this is the final answer, which is the derivative of a function f of x. Let's move on to the final problem. So problem number 5, if g of x is given by x times 2x plus 3 times e raised to the power of x, then find the derivative of g of x. Now here we have three functions. The first function is x, the second function is 2x plus 3, and our third function is the exponential function. So let's try to find out the derivative. So we have g prime of x, so this will be equals to, so what we will do, even though there are three functions, so we will consider 2 and 3 to be a single function. So that means this is of second function and x is the first function. And we apply the usual product rule between two functions. So we'll take the first function x and multiply it to the derivative of the second function, which is the product between 2x plus 3 and e raised to the power of x. Plus, now we consider the second function, 2x plus 3 times e raised to the power of x. And then we multiply it to the derivative of our first function. Now, we see that we have x multiplied to derivative of this two functions, the product of two functions. So again, what we can do, we can apply the product rule. So here, let's treat 2x plus 3 as the first function and e raised to the power of x as the second function. So we have 2x plus 3 times derivative with respect to x of the second function plus the second function times derivative with respect to x of our first function, which is 2x plus 3. Plus we have 2x plus 3 times e raised to the power of x and derivative of x with respect to x, so that is 1. So we get x times 2x plus 3 times derivative of the exponential function is the function itself plus e raised to the power of x. So derivative of 2x, this will give us 2 times derivative of x with respect to x, which is 1, plus derivative of a constant 3, which is going to be 0, plus 2x plus 3 times e raised to the power of x. So let's write everything neatly. So we have x times 2x plus 3 times e raised to the power of x plus x times e raised to the power of x times 2. So we have 2x times e raised to the power of x plus 2x plus 3 times e raised to the power of x. So this is the final answer, and it doesn't really matter if we have 2 function or 3 function, the product of 2 or 3 function. So we can always break it down, make life simple, and perform the derivative using the product rule. Thank you.